examples from yesterday, you guys made them up. Brandon, keep going on the rational one.
Then I put x plus 3. And then over, sorry, x plus 3 parentheses like x plus 4, that would work. Over x plus 3. I kind of screwed up because it's supposed to be negative 3.
Well, that's okay though, because technically I said an example for this would be one that works by simple plugging in, right? So, technically another way this could have been would be x squared plus 7x plus 12, right? Same thing. But either way, Brandon, let's not say you screwed up. Let's just plug it in, because what do you get?
So you're supposed to have 13 over 6.
Times 7.
Times 7.
Which would end up being? True?
Yeah.
Nice. So hold on, wait a minute. How could you guys have made a different example? All you would have had to do was make a fraction of polynomials such that you could plug in without anything, without the denominator equaling 0. Katrina. Well, a polynomial, you could have multiple terms, like 3x squared minus 2x plus 1. But Aaron gave a monomial, which is still technically a polynomial. It's kind of like polynomial is the general label, and a monomial works. But you can definitely keep yours with multiple terms, and that would work. Does that make sense? Okay. Radical function, and back to group number 5. Give me one.
The limit as x approaches 2 of, I don't know how to say this, but like the nth root of 4.
You gotta pick one now. What do you want? Square root, cube root, fourth root, fifth root? You get to choose a number.
Okay. Cube root.
Cube root? Okay. Of 4, what would that one equal? It's a constant, right? Now, how could we have made it so that the answer is the same, but there was an x in there?
Put an x in there.
That wouldn't be the same answer, though.
Change x to approach 4.
2x.
2x.
Wouldn't that work?
Yeah.
Okay. I just put an x in, Angela, so we can see the plug it in, plug it in. Okay, composite function, group number 3.
F of off to the side.
Off to the side? Okay.
F of x equals x squared.
Okay.
G of x equals x cubed.
Okay.
And then the limit as x approaches 2 of f of g of x.
Snazzy. What do we do?
Plug the 2 into the g of x.
Plug, remember, start in the innermost. Plug the 2 into the g of x, so that would be 2 cubed. And then what's going on with that 2 cubed? Where's it being plugged into? 2 cubed is being plugged into the something squared, and we're going to end up with 2 cubed is 8, 8 squared is?
64.
64. Now, it doesn't necessarily have to be written with f defined separately than g. So let me give you one more example with this one, and then move the little within domain. It's right there. What if I was to give you one more example? What if I was to give you the following? The limit, as x approaches 1, of x squared plus 1 cubed. Why is that a composition? The limit as x approaches 1 of x squared plus 1 cubed. Who's the innermost?
X squared plus 1.
Who's the outer?
Cubed.
Something cubed. So I could state it. G of x is equal to x squared plus 1, f of x is equal to x cubed, and then g is inside f. Or I could just say, oh hey, it's something inside something, whatever, plug it in, plug it in. And I end up with
8.
1 squared plus 1, 2. 2 cubed is 8. Cool. As long as it all works out and nothing's like imaginary or weird, we're good to go. Trigonometric, group number 1.
Keep this done.
No, Ellen, Christian,
I didn't
Brandon.
want.
Brandon already did one.
Yeah. Hold on. I'll explain.
Talk it out.
Limit as x approaches 5. Say that.
Alright, Christian, go.
X approaches 5 over 2.
Ooh, pi over 2, that's like a unit circle angle. That makes sense.
Sine.
Just sine x?
Yeah.
And how do you solve it, Christian?
You plug in pi over
Good.
two.
And then you go to your unit circle, and everybody, sine of pi over 2 is? Uh-oh. My ones that said 1, yay. My ones that smiled and just tried to look cute, study. And then my ones that were trying to look down and avoid my gaze, study too. More transcendental. Okay, does anybody have an example for the bottom one?
Aaron does.
Aaron?
Got one right here.
Yeah,
Okay,
go,
Aaron, go for
I
it.
think
Go for it.
Aaron is
as
perfect.
x approaches 4
Okay.
of 2 to the power of x.
Ooh. Equals?
16.
Uh-huh. Because 2 to the power of 4, there are 4 2's. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. Dun 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 dun. Seriously? Only 1? You guys are lame. Okay. Alright. This entire page, what were we doing? Just
Examples.
plugging in. I'm going to go ahead and delete the next page because it was examples and you guys were amazing and just made them all up for me. Alright. And we practiced our creative skills of coming up with problems on our own. Alright, here we go. What if direct substitution fails?
Keep going.
Sometimes.
Wait, you can just say no.
I said sometimes. But what are you guys looking at right now? When you plug in, if you get 0 over 0, then you can, say it loud and proud, Corey.
Keep going.
This is a keep going, or this points to keep going. 0 over 0 points to keep going. Traffic? I heard that. 0 over 0 points to keep going. Violet, the nice thing is that we are doing examples at the beginning, so this is the first bit of notes, new notes that we've done besides the examples, okay? 0 over 0, keep going. Why? Because 0 over 0 is called indeterminate form, and indeterminate form means I have no clue what the answer is. Now this is enough to tell us that the function does not exist at the point or at the x value you're trying to plug in. That's true. The function does not exist. But what are we solving for in this entire section? Starts with an L, ends with an limits. Limits, right? And limits, do we look at only what's there, only what's filled in?
No.
What do we look at?
What's coming from the left?
Coming from the left, coming from the right, what function value the function is approaching, right? We're looking at the approach. We're looking at where they're headed. We're not looking at whether or not the diner is burned down or locked or whatever else, okay? So 0 over 0, if you plug in, now what's the dilemma with some of you guys? You look at a limit problem, and you get over 0, and you're like, oh, Danny, why do you have to keep plugging in? Because if it's 0 over 0, it might not exist. It might exist, so we have to keep going and check it. Now, how do we keep going? 3 different ways. In general. But even these 3 different ways sometimes will fail, and I might show you an example of how they fail, and then things get really interesting because you have to learn how to take derivatives and do L'Hopital's. But, for right now, and for this section of homework, the examples that you will see, except for one that I'll try to stump you on. Or I could just say one you've already seen. These will work. No, you don't really need to leave spaces, that's okay. And I'm not spending, technically guys, like last year, because the summer packet wasn't as good, not this past summer, but the summer before. I spent like a page or 2 on each of these. So why am I literally summing them up in 1/2 a page?
It's easy.
Because you've already seen them. And we'll practice them, definitely. But we're just doing quick sum-ups, okay? If you get 0 over 0, and you can divide it out, divide the denominator. Get rid of the denominator. How? You can get rid of the denominator by factoring and canceling. Traffic?
And Trevor.
Oh, I want to hear the story.
You guys carpool?
Yeah.
Don't worry. A lot of people relate. We're just
Congratulations.
Fuse?
Yeah.
Sorry. It's okay, you made it. Nice thing is, this is our first page of notes. We were doing like lots of examples at the beginning of HTTP and all that. One of you got marked as an absence, and one of you got marked as a tardy.
Which one was?
You got a tardy. You got absence.
819, 820.
Are you see? No.
I
You
am.
came in together?
Yeah.
Yeah.
We'll talk about that.
I'm in.
Go talk to the comments.
Pretty.
Yeah, we'll figure it out. Anyway, we have the dividing out. That just means getting rid of the denominator. Remember, 0 over 0, plug it in all the way. See what the numerator and denominator are. Why do I have synthetic or long division? Sometimes factoring fails. Or you have a cubic and you're like, nah. Okay, then do it a different way, right? Synthetic. You can only do synthetic division with linear factors. Remember, you can only do synthetic. Technically, you could factor out that A, but to be honest, I would say only have got that one. That's the only time that synthetic division would be easier. Otherwise, do long division. We'll have one, we'll practice it. Rationalizing, what's going on with that one, guys? What do we have in our function? You plug in, you get 0 over 0, and you're like, multiply by the conjugate. You have a square root somewhere, and he's messing everything up. Rationalizing, you have a square root. Does it have to be in the denominator? No. It could be messing you up in the numerator. It could be messing you up in the denominator. It's somewhere in your expression, in your rational function. You have a square root. It's messing you up. You want to multiply by the conjugate. If I can spell it. Now, just a few of you might need a quick reminder. Who is the conjugate? The conjugate, let me give you an example, of square root of x plus 3 is, what would be the conjugate of square root of x plus 3?
Square root of x minus 3.
Exactly. First term stays exactly the same. Just that middle sign flips, whether from a positive to a negative or a negative to the positive. But remember, if you multiply by the conjugate, you have to multiply creatively by the conjugate. You have to multiply top and bottom by the conjugate. We don't have an equation where we can multiply both sides. We have to multiply by one creatively. Going back to algebra. Simplifying. I already gave you guys the two cases where we might need to simplify. First part, complex fractions. Do we know how to do that? Hopefully summer packet will review it. Complex fractions. Remember, just a quick in case the summer packet didn't stick, multiply top and bottom. By the common denominator, meaning by all of the denominators together. I'm going to put real quick underneath, the most common problem that occurs is that you don't distribute those common denominators. Multiply top and bottom by the common denominators, you must distribute. Must. Now why did I put even trig? How could you simplify trig? Are there a lot of formulas? Trig identity, trig properties. Sine squared of x plus cosine squared of x is 1. Tangent of x is sine of x over cosine of x. Gotta keep our wits about us. Who knows, they might show up again. Who knows, they might show up again. Let's keep going. What's the other kind of form we can get? Ooh. Number over 0. The first one was, what if we get 0 over 0? Remember, these notes are saved online. So if you need to, just sneak a peek at your neighbor, skip however many lines you need if I go too fast. Go find it online. And take that chance to kind of think through notes again before starting homework. Or continuing on homework, I should say. So remember, we're under this section of what if direct substitution fails? It doesn't get you to an answer. First of all, 0 over 0, what should we remember? Keep going. Quick question, when you're solving a problem and you get 0 over 0, what do I want you to literally write when you write 0 over 0?
KG.
Keep going if you want to, all the letters, or KG. Just to remind yourselves, that's right, I'm not done, I need to keep going, okay? But how about this one? Is this 0 over 0?
No.
What is it? Number over 0, constant over 0, 10 over 0, 6 over 0, 1 over 0. We could say technically non-existent. We could say technically non-existent. Why? What's this form called? Infinite form. What is occurring at the value if I get number over 0? But let's really quickly think about what are the 3 different ways a vertical asymptote could occur at C. Remember the limit as x approaches like some constant C. What are the 3 different ways a vertical asymptote can occur? Coming from the left, it could be going, my function could be going
Exponentially
up. And then coming from the right, it could be going. Hey, the limit actually would exist, right? What's the limit? Now, is it technically non-existent? Yes. And we're still technically answering that in our homework. But infinity is the best answer that we'll see in a couple sections. What's another way this could happen? What if I'm still going to positive infinity from the left, but what's going on from the right?
Oh, no.
Ruh-roh. What's the limit now?
Does not exist.
Does not exist. Or the limit is non-existent. Put in that AP way of saying it. But you're right, the limit at the end does not exist. And what's another way? Well, I guess there are technically 2 more ways. But I could be going down and then up, it would still not exist. Or I could be going together down, and what would my limit equal then? Good. Does that make sense? Technically, the books right now would still say that this one is non-existent, but is it non-existent in a way that we will eventually answer? Yes. Yes, 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 yes. But nice thing is, in homework, you're not going to see these. We're technically like 2 sections early on that one. All right, let's keep going. But since I'm talking about limits and plugging in, I didn't want to show 0 over 0, keep going without showing, computer, why do you freeze? Number over 0. Don't keep going. Figure out the infinities. And we'll talk about it once we get to this section. How can you figure out how it's approaching the vertical asymptote without using a calculator to graph it? We'll get there. Hey, what? Hold on, what else do we have? Just see how much time we have. Okay. I want you guys to go ahead, one person from each group coming up and grab a little baby whiteboard, grab a marker, and grab a towel. Instead of a napkin. Ready, set, go. Keep your notes out because as you saw, we technically have 2 more little sections. We're going to do some examples of what happens when direct substitution fails. Or maybe I'll throw in some easy ones as well. I want you guys to kind of turn your desks just so you can see over the person's shoulder. Now, other days when maybe we have this for a longer time, I'm going to have you guys grab out the huge whiteboard. These get way more fun. But for today, we don't really have time. We're doing it quick. So, ready? I need someone to start with the expo and start. You don't have to start on the side with my name. It's literally a scratch paper. You can start on the other side. Yeah. If I were you, I'd have it kind of landscapey, but it's up to you. And quick heads up, whoever's doing the problem now for the next example isn't allowed to touch the marker. We switch to someone else, switch to someone else, switch to someone else. Okay? Now, here's the dealio. Some days we're going to have contests with this and actually like have group contests for something or others, whether points, whether like a prize, whether who knows what. Today, we're just trying to get it right. Okay? Just trying to get it right. The person with the marker currently is the only one allowed to work on this problem. But, listen, everyone else can collaborate and advise, just they're not allowed to touch the marker. Are we tracking? The person with the marker is the only one allowed to write. Everyone else may collaborate and advise. When you are done, this is why we have the little ones today, hold it up fast. You can imagine people have gotten hurt holding that one up. Seriously, I'm not kidding. Like cuts and everything. So, these ones, hold it up fast. But remember, the goal is to get it right, and we'll see if you guys are able to get it. Ready, set, go? Here we go. Example number 1. Example number 1. If the other people want to write it in their notes, they can, but you cannot show the person your work. You can only use your words to explain if they are doing something wrong. Cool? The limit. As x approaches 5 pi over 6, cosine of x.
We were definitely first.
This is positive.
negative.
Positive.
No!
Oh, that unit circle! All right, erase it. I had to. Switch the sheet, switch the marker. Someone new. Here we go. Everyone helping, everyone collaborating. If you can't see the person working, look over their shoulder. Here we go. You have to write the problem, then solve. The limit. As x goes to 1 of x minus 1, wait for it, x squared minus 3x plus 2. Go.
Okay, so
That's negative 2. X minus 2. X minus 2. X plus 2. X plus 2. So 3. 3. So put 3 in circle and put it up. Corey.
You are the champion. You got it.
Just 3.
Oh, it's negative 3. Oh, you're right.
We would have been first. No,
Nice. All of you. Nice. However, there was one thing I'm not sure. I didn't look for it. I would have loved to have seen first.
I wrote that.
But I am proud of you for writing it. Now hold on. Yeah, go ahead and erase it.
Is this the next one?
Question. No. When you guys started factoring, did you write limit again? Because if you didn't, and this was a quiz or test, if you didn't write that, you just lost points.
Really?
4K.
Because
You have not solved the limit yet. It's like saying square root of x squared plus 2x plus 1 equals x plus 1 squared. Does that make any sense? No, you factor, that's great, but what'd you forget? Yeah, you can't take away the square root unless you deal with it. Same thing here, okay? But for those of you guys that finished solving, these canceled out and you end up plugging in 1 minus 2, which equals negative 1. Why did I stop writing the limit? I took it. Okay. Number 3, mark it a new person. Should not have written yet. Because all of you have at least 3 group members. The limit. I need to actually start stealing or else they're going to get confusing. Hold on.
yeah, I really need your help.
Here we go. The limits. I'll say it for those of you that might be not able to see.
Put 0.
Yeah. Square root of x plus 25 minus 5 all over x minus 5.
X plus 20.
No, sorry. All over x. I lied.
Oh, just over.
It's 1 over root x. 0, 0, 2, oh, 110.
Show the work that gets there. Nope. What? Show the work that gets there.
What? I did it all mentally.
I'm so proud, but we're
You
not
only have like
Alan.
40 minutes on the exam.
Alan had the marker.
So now,
You multiply by the conjugate. Multiply by the conjugate. Point prime. So let's divided by square root x plus 25 plus 5. No, square root x plus 25 plus 5. Put it on top and bottom. The top equals 1. Top equals 1. And the bottom reduced out to square root x plus 25 plus 5.
I got it.
Plug in 0, 25 plus 5.
We did write limit again.
So plug it in. You get 1 over 0. Square root 0 plus 25. So square root 25 plus 5. 0 plus 25. Plus 5.
Everywhere there's an
Equals 1 over time.
Just for until you plug in, then you can
Okay, we have the work now. 81. All mentally 3 seconds. This is my note how to come out.
I get you.
Nice hours.
One over 10. No, it's 1 over 10.
1/10.
Yes.
Almost. Alright, hold on, pay attention, my one didn't get it. What do we multiply top bottom by?
The conjugate.
Which is plus 5. Now wait. In the notes, I say distribute. Right? You gotta be careful. Now what was the purpose of multiplying by the conjugate? It's a difference of squares.
Rationalize.
And difference of squares allows us to multiply the first. A square root times a square root is the original. Outer, inner cancel. Last will be minus 25. Oh, that's convenient. Look at that. Over x times the square root of x plus 25 plus 5. Oh, hey, you guys see how I still kept writing my limit? Now I can go ahead, since the 25's cancel, what can I do with the x's since there's no more addition up top? I can go ahead and cancel those as well. Understood. 1. Now I can plug it in. 1 over the square root of 25 plus 5. 1 over. Now, some of you hadn't done that before, or haven't done it in a while. Do you see how the conjugate helps? Start.
Now I get it.
Oh, there was one down, and there was also one up, so I
In the square root.
Oh, I plugged it in.
Oh, okay.
Plugged it in. Does that make sense? Corey. You have to write limit because the x is still present. You have not plugged in yet. But as soon as the 0 is in. All right, one more, because some of you guys have 4. Some of you guys are going to start repeating because you only have 3 group members. So here we go, number 4. Either the person who hasn't worked one yet, or the first person, or you can choose if you have a group of 3.
Don't choke yourself.
Last but not least. You guys ready? The limit. As x goes to 1 of x minus 1 all over x. Go.
How do we do it?
It's not 0, 0. It's not.
Keep going.
It's not. You plug in a 1.
Minus 1.
0.
Oh, and then over 1. Oh, which means
I wrote keep going.
passenger.
1 over 0 is
It's 1 over 1. Oh wait, does the proportion
What over
infinity?
2?
I'm assuming the proportion.
1.
No, it's not.
Oh! 1/2. Wait, no. Misty! It's not 1 over 2. What?
0.
Oh, wait.
Is it negative infinity?
Zero is not in the bottom.
It's a vertical. No, vertical is number over 0.
Vertical asymptote is number over 0. That's
0 over 0.
no.
Isn't the answer 0? The answer is 0.
I have the answer.
Misty!
This is the answer.
Non-existent.
Right.
Get out your calculators and try it. 0 divided by anything besides itself is what?
It was everybody else shouting. It was confusing.
All right, put your little whiteboards off to the side, back in our notes. Put your little whiteboards off to the side, back in our notes. Now hold on, focus. Focus, focus. A lot of you guys figured out 0 over 1. Some of you were like, keep going. And you're like, oh, it's not 0 over 0. Okay, 0 over 1. Some of you guys were like, vertical asymptote, but that's what?
Number over 0.
Number over 0. 0 in denominator, dividing by 0. Everything combusts. It's a bad problem. It's, I gotta do something else. But 0 over 1, 0 over 10. 1 times what is 0? 0. Oh, check it. 1 times 0 is 0. True. Anyway, notes open. Keep going. We talked about what if we had 0 over 0 or number over 0. Number over 0 we'll come back to. I didn't even want to give you a problem on it today. We'll come back to that in a future section. Your homework's not on that. But we looked at, just now, conjugates. We looked at factoring. We didn't look at long division, but I bet there's going to be one in your homework somewhere. And you did one in summer packet. You can always look there. I didn't really do an example of trigonometric exponential logarithmic, at least not problem ones. I did a plug into cosine. But that's just plug it in, unit circle. We're going to take just a little more time. A little more time. Looking at what could go wrong. Or what could be weird. Believe it or not, this special little box at the bottom, technically these limits, especially the first two, are found by something called the squeeze theorem. Your book goes into a lot of detail on the squeeze theorem in sections 1.2, 1.3, somewhere around there. It's a great theorem to understand. We get these facts out of that theorem, basically saying you can't solve it outright the way it is. So you find functions that kind of flank it on either side and meet together at the number you're approaching, and so it squeezes this one in and we can say an answer. Once we learn L'Hopital's, we'll have a whole nother way of doing this. But that's after we practice lots of derivatives later on this semester. But for right now, to be honest, guys, these are things we need to memorize. Oh, memorize. Where do we put memorizing things? We now have forever number 3. We now have forever number 3. Wait, I have a forever up here. Oh, you know which one had all those reviewed trig properties that I was talking about a second ago? First one. So when I mean simplified properties, I just mean like tangent, sine over cosine, those sorts of things. Cosecant is 1 over sine, etc. But there are still some places where we could run into some trouble. I'm just going to give you a few examples of these on the next page. I'm going to go ahead and dual page it just so we can kind of reference back and forth, and some of you I know are still taking some notes, and that's okay. Let me dual page. Let me just show you how these work. I'm not going to go in tons of detail on the third one. It's a really important formula in math. As far as I have seen, the AB exam hasn't tested on it. The BC one has. But they are changing things up this year just a little bit, so I'm gonna go ahead and still have it in our forever cards. Still a great fact to memorize. Let me do some examples of the trig, because you'll see those much more often. Let me go ahead and let's do a couple. The limit as x approaches 0, sine of 5x all over x. Now, I'm not making it super easy. If it was sine of 5x over 5x, look at the formula, what could we say the answer is? 1. If it was sine of 5x over 5x, the answer would be 1. I went kind of straight to something a little bit hard. How do we make this match that? If there's a 5x here, what do I need down here? A 5x. So what am I missing? A 5. Algebraically, how can I legally get a 5 in there? Multiply top and bottom. Now, if you guys actually were to plug it in, it would be 0 over 0, keep going. So maybe we should have done that first, technically. So I'm going to do 0 over 0, keep going. We keep going. Let's see if this makes sense. I'm allowed to say 5 true? 5 over 5. What am I allowed to do with limits? Solve them separately. So I could do, it's called the product rule for limits. Basically, I can do them separately. Or I can pull this 5 coefficient out. So it's going to be 5 times 1. Now some of you guys are like, wait a minute. I think I see a pattern here. Oh, you're right. You're totally right. We can't make a rule because we can't pull that 5 out. That's totally illegal. However, with limits, that's going to happen whenever you see sine of over and you're approaching 0. Now let me give you another example. What if I was to give you instead, number 2, the limit as x approaches 1 of sine of x minus 1 all over x minus 1. This one's different in a different way. X isn't approaching 0, but wait. What happens when I plug in 1? 1 is the 0 of the u. Do you see what I mean over here? This just means what makes u 0? Oh, this does. So if I still get 0 over 0, keep going, and if this fits the sine of u over u pattern, what can I say the limit equals? Got it. Kind of. And similarly, I could do something like the second property. Let's do the limit as x approaches 0 of 1 minus cosine of x all over, I can't. You're not going to like this one as much. When I plug in, technically, cosine of 0 is 1, 1 minus 1. I do get 0 over 0. Keep going. This looks vaguely familiar, like that 1 over there. Huh. Couldn't I take the 3 and say that it's separate from the x? One times blah is blah. 3 times x is 3x. It works. I'm pulling that 3 apart and away, but it's in the denominator, so I'm pulling it 1/3 apart or away. 1/3 remains. What's the limit of this puppy? Sine of u over u, limit as u approaches 0 is 1. Cosine is 0. A way of remembering, there's only 1 1 per formula. Silly way of remembering. There's only 1 1 per formula. Okay, we're almost done. This was the last really important page I wanted to see because it's weird, it's funny. Now, are you going to have some just plugging in ones of homework? Yeah. Are Are you gonna have some just factor cancel out, then plug in, or some rationalizing? Maybe some complex fractions, that's the one we do in practice. But you might see some funny trig stuff as well. What's the one page I wanted to go over with you guys before tonight? Piecewise functions. But to be honest, that's not a huge emphasis of this section's homework. I just wanted to kind of recap. We saw piecewise functions in the graphically numerically section. So let's do this. Homework is still going to be due tomorrow. But we're going to talk about piecewise functions right at the beginning of class before going over our homework questions, all right? Okay. People with my little pretend whiteboards and expo markers and towels, turn them in on the way out. And you get a do homework. Just realize some things might be tricky. 0 period tomorrow morning. Maybe we can work on some of this stuff. Coffee. I don't have a little